Hello, Assalamu alaikum everyone. Can you guys hear me? Am I audible? Can you guys hear me? Hello?
Hello,
Yes,
Assalamualaikum,
ma'am.
ma'am. We can hear you.
Walaikum assalam. Please respond fast, okay? Because I'm asking you a question 2-3 times and then you guys answer. Is my screen visible?
Yes, ma'am.
Alright, let's get started. So today we're going to cover a topic called sequential circuit. Alright, so previously the kinds of circuit that we've completed were called combinational circuits. Can anybody tell me what combinational circuit meant? So combinational circuits were the circuits where the output only depended on the current input. For example, even an AND gate. AND gate is also a combinational circuit. So if my input is 1, 0, the output depends on what my current input is, and my output will be 0 for AND gate. So this is an example of a combinational circuit where the output only depends on the current input, as opposed to sequential circuits. In sequential circuits, there is a memory element, okay? So inside the circuit, you store some value. So let's say the value right now stored is 0, okay? So the output will depend on the current input and combined with the memory or combined with the value that is stored inside the memory. So in sequential circuits, we have a memory element, and the output of a current of a situation depends on what is stored inside the memory element, and what my current inputs are. So if we look at a sequential circuit, let's wait. Okay, so a sequential circuit has a combinational logic unit where it will take some inputs, and these inputs are called external inputs. And it also has some memory element, that is, some value is stored inside the memory, and it combines the inputs and the memory, and then it gives out the output. Give me a moment. Okay, so the output depends on the external input and the present state of the memory element. This is the difference between sequential circuits and combinational circuits. So the kind of sequential circuit that we're going to learn today, they're called flip-flops, okay? So inside our combinational circuit, we see that we have a memory element. So flip-flop is a component that stores value, that can store value. Previously, we did not learn any way to store values, but today we're going to learn a new type of component which can do that. So let me show you a simple component that can store a value. This is not a flip-flop, but this is a simple way I can store a value. Okay, storing means even if I take the input away, the value inside should remain the same. So I'm attaching two NOT gates here, and the output I'm giving it as an input again. So let's say in the beginning I give the output as I give the input as 1. 1 bar is 0 and 0 bar is 1, and then again I'm feeding the output as input again. So even if I take the input away, still then my output over here will always remain as 1. Okay, my output will always be 1 here. So this is a simple way we can store a single bit, but this is not a really good way because first of all, we don't have much control over the circuit, and also it's not that advanced. Okay, it's just an example of how we can store a value. So now let's look at how flip-flops work. Okay, let's first look at the block diagram of a flip-flop. So a flip-flop takes some commands, okay, and it stores a value. So it's a device which can remember value indefinitely or change value on command from its inputs. So the command will be the inputs, and following the command it will store a certain value inside the flip-flop, and the value that is stored is shown with the variable q. So whenever I'm talking about q, I'm referring to the value that is stored inside my flip-flop, okay. So either I may use q or sometimes you also use qt. This notation, q means the value at a present time, and it shows which value is stored, okay. So remember, I'm going to use this notation a lot. So this is how any flip-flop that you have, it has a command part where it will take inputs from the user, and depending on what input it gets, it will store a value inside it, and that value will be stored in the variable q. Now flip-flops have another controlling element. Not an element, but it has another input called the clock, okay. So the clock works like an enable input. So if the value of the clock is 0, then it doesn't matter what command I'm giving to the flip-flop, the flip-flop will not receive the command, okay, it will stay as it is. But if the clock is 1, if I pass 1 through the clock, it will show me the change that is occurring inside my flip-flop, okay. So a clock pulse is basically an enable bit for the flip-flop, okay. A clock pulse is usually a square wave. It means usually we pass the clock in this way, like first 0 goes, then 1, then 0, 1. We pass a series of zeros and ones, so that in every second, let's say the clock changes its state in every 2 seconds. So every 2 seconds we can see what changes inside the flip-flop, okay. So flip-flops can be positively triggered. Positively triggered means it turns on when the value 1 is given to the clock, okay. Anyway, so just remember that when clock is 0, your flip-flop is turned off. It doesn't, whatever is inside the flip-flop, it remains unchanged. There is no change inside the flip-flop. But when the clock is 1, at that time the flip-flops receive the command and work accordingly. Okay, so this is the basic of flip-flop. Now once we're So today we're going to learn this was the basic of flip-flop. Today we're going to learn 4 different types of flip-flops, okay. These are the flip-flops we're going to learn. We're first going to learn SR, then JK, and then D, and then T. So we're going to learn 4 different types of flip-flops. Okay, so before I move on to the specific types of flip-flops, does anybody have any question? Does anybody have any question? Okay, if not, then let me start. So at first we're going to learn about the SR flip-flop. So the SR flip-flop is called the set reset flip-flop, okay. S stands for set and R stands for reset. So remember, I was telling you that we send some commands to the flip-flop and it stores a value. So here the command will be given in 2 bits, okay. So one bit is called S, the other bit is called R. So in SR flip-flop the command will be given in 2 bits, and whatever value will be stored inside the flip-flop will be denoted by the variable Q. So Q is the value that will be stored inside the flip-flop, and Q bar is the complement of Q, okay. So I have 2 bits to pass the command S and R. So S, remember that S means set, okay. This means storing the value 1, okay. If I want to store the value 1, then I will pass 1 through set and I'll pass 0 through reset, okay. And as a result, if I set the value, the flip-flop holds the value 1, and as a result the value of Q will be 1. So for if S is 1 and R is 0, my flip-flop stores a value 1 and the value of Q is 1. Now let's say I want to store the value 0 inside the flip-flop, okay? If we say that I want to store the value 0, what we can do is we say that we reset the value. Resetting means setting the value to 0, okay? Resetting the value to 0. So if you want to store 0, then we pass 1 through R and we pass 0 through S. So if I want to store 0, then I have to pass 0 through S because I'm resetting the value, so I'm not going to set the value. So S is going to be 0 and 1 through through R I'm going to pass 1. So as a result 0 will be set. That means the value of Q in this case will be set to 0. Alright, so this is how we store the value 0 and 1 inside the flip-flop. Now we have, since there is SR, there are 4 combinations, right? So if I have SR, there should be 4 combinations: 0, 0, 0, 1, 1, 0 and 1, 1. So you've already learned about these combinations, that if S is 0 and R is 1, then the value stored is 0. If S is 1 and R is 0, then the value stored is 1. Now what happens if the value is 0, 0? Now interestingly, if I pass 0, 0 into the flip-flop, okay, if I pass 0, 0, what happens is, whatever value that is stored inside my flip-flop, it remains as it is. So if S is 0 and R is 0, then whatever value that was stored previously my value stored was 0, so the value remains as 0, okay? So 0, 0, what happens is, if you pass 0, 0, then there is no change inside my flip-flop. So suppose I pass, now I pass, let me put the value. Suppose I am passing 1 through S and 0 through R. What value will be stored inside my flip-flop?
Ma'am, 1.
Yes, I am setting the value, so 1 will be stored. And then if I pass 0, so Q will be 1. And then if I pass 0, 0 through SR, then what value will be stored?
Ma'am, 1.
Right, 1 will be stored, because if I pass 0, 0, then there is no change, okay? So 3 combinations done, and remember that the 4th combination is an invalid input. If I pass 1, 1 through this, then it's invalid because it doesn't work, okay? If I pass SR, once we see the internal circuit, we'll see that this will give an invalid output. So in SR flip-flop, this is an invalid input, okay? We do not use 1, 1, we use these 3 combinations. Now let's look at the internal circuit, okay? We looked at the block diagram. Let's see how this works. Okay. So before I start, I'm going to show you the simple diagram of the circuit diagram of the flip-flop. Okay. So this is what the flip-flop diagram looks like. So here I have S, I have R, okay, SR flip-flop, and R and clock pulse. Remember I said that every flip-flop needs a clock pulse. So the clock pulse with R is passed through AND gate. Here it's AND gate, and here if you look carefully, the combination of clock and R is the output here. This output goes to the NOR gate, and here we have S and clock pulse. This goes to the other NOR gate, and here interestingly the output Q is passed as an input through this OR gate, this NOR gate, and the Q bar and the value and the output Q bar is passed through this NOR gate. So in sequential circuits, you will always see that the input is always fed back as an output, okay? This is a very common technique in sequential circuit, where the output is always taken and given as input to the circuit, okay? So here this is my flip-flop, and whatever value that will be stored inside my flip-flop will be denoted by Q. So whenever I'm talking about Q, whenever I'm saying output Q, what I mean is the value that is going to be stored inside my flip-flop. So Q is the value that will be stored, and Q bar is the inverted version of the value. So if 0 is stored, q bar will be 1. Okay, so q and q bar are complements of each other. Now, so remember that if my clock pulse here is 0, okay, if it's 0, then 0 into r will be 0 and s into 0 will be 0. So here, if my clock pulse is 0, then my flip-flop will show no change, because I'm not being able to pass the value of s and r. Okay, so here the clock pulse helps me control the flip-flop. If clock pulse is 0, it doesn't matter what I pass through r and s. This is my actual part that stores the value. Okay, I'm passing 0 0 here, so if I pass 0 0, then my flip-flop remains unchanged. If I pass 1 here, okay, then 1 into r, okay, 1 into r is r and 1 into s is s. Here I'm passing the value of s and r, so whatever value I'm passing, the flip-flop will follow the command. Okay, so the flip-flop for the flip-flop to work, the clock pulse must be 1. Okay, so this is the overview of the diagram of the internal circuit. Now let's see how this circuit will work. Okay, give me a moment. Okay, so this is a NOR gate. Okay, so let's first quickly construct the truth table for a NOR gate. So how does a NOR gate work?
Ma'am, opposite of OR gate.
Right, in OR gates, if one of the inputs is 1, then the output is 1, and otherwise the output is 0. For a NOR gate, it's the opposite. If either of the input is 1, the output is 0. Okay, and if the output is only 1 when both the inputs are 0. Okay, opposite of OR gate. Okay, so we will need this. So for the flip-flop to work, I will pass 1 through clock pulse. Okay, now let's do the next part. So let's pass 1 through r and 0 through s. Okay, so 1 and 1 over here, I'll pass 1 here, and 0 and 1 will be 0. Okay, so notice in a NOR gate, if one input is 1, then automatically the output will be 0, right? If either of the input is 1, then the output is always 0. So q will be 0 here, and then 0 will be passed in this part. Okay, so 0 NOR 0 will be 1, and then 1 will be passed here. So 1 NOR 1 will be 0. So here q is 0 and q bar is 1. And remember, for the SR flip-flop, r equals to 1 means we are resetting the value. Okay, resetting the value means we are storing the value 0. So remember, I said whatever value that is stored will be denoted by the variable q. So q0 is stored in q here, so we have stored the value 0 inside our flip-flop. Okay, does anybody have a question here? Alright, so the internal circuit, I've traced it and shown you that when S is 0, R is 1, my flip-flop holds the value 0, and even if I remove SR here, because of the way the feedback is given, this will always remain as 0. Okay, Q will always hold 0. Now let's trace the other example. So again, clock pulse will always be 1. Okay, clock pulse will always be 1, and if I pass 0 here and if I pass 1 here, can you tell me what value will Q store? So 0 and 1 will give you 0. 1 and 1 will give you 1. So if input of a NOR gate is 1, then automatically the output is 0. Okay, so I'll have 0 passing through here, so it's going to be 0. So 0 0 NOR will be 1. So if I remember, S stands for set. If I want to store 1, then I pass 1 through S and I pass 0 through R. So this is how I have stored the value 1 inside my flip-flop. Okay. Now for the next part, I want to store the I'm giving 0 0. Okay, I'm passing 0 through S, I'm passing 0 through R. Now can you tell me what value will Q hold?
Will it be 0?
Okay, let's see. Okay, so what happens if S and R are 0? It was no change. If you remember, if I put SR, if I put 0 0, then it should have no change. So if I pass 0 0, notice that 0 0 and 0 will be 0 here, right? Okay, and 0 and 0 will be 0 here. But here Q was 1. So if one of the input is 1, my output will be 0, and 0 will go over here, 0 nor 0 will be 1. So the output will not be 0, it will remain as 1. How did you get 1? How did you get 0 here?
I'm sorry, ma'am. I just confused something.
Is it clear now?
Yes.
Because if I pass 0 0 here, I'll have 0 as both, but since Q was 1, I'll have 1 passing through here, so my output will be 0 and this 0 will be fed and my Q will remain as it is. So if S is 0 and R is 0, the output will, the value that will be stored will depend on what was stored before. Okay, no change. The value that was stored before will remain as it is. If Q was 0, then it would have remained 0, but since Q is 1, it remained as 1. Okay, so the fact that so the way I have described the SR flip-flop, it can be written in a table, and this table is called the characteristics table of the SR flip-flop. Okay, so the SR flip-flop's characteristics can be drawn inside a table. So here I have written the combination for SR. I think I forgot one more thing, my bad. So let's see what my output is, what the value of Q is if the value of RS is 1. So if R is 1 and clock pulse will always be 1, so the input over here is 1, okay, and the input over here is 1. 1 and 1 is 1. So you see, if I pass 1 here, if either of the input of a NOR gate is 1, then the output is 0, and here the output will also be 0 because the input is 1 here. So here Q and Q bar hold the same value. And isn't that wrong? Because as I said, that Q and Q bar should always be complements of each other. Okay? So if I pass 1 through SR, both S and R, then my Q and Q bar becomes the same. That's why this input is invalid. Okay? 1 and 1 input is invalid. Alright. So here we have drawn, we can see the characteristics of the SR flip-flop through its characteristics table. So here I have written the S and R's combinations, and it's the operation that what these combination will cause. And here this is a bit new. Here we have QT and QT plus 1. So QT shows the previous state. Okay, so this is the previous state, and this shows the next state. Okay, so the previous state is basically what is stored in my flip-flop before the commands, and the next state is after I pass the command, what will be my new state. Okay, alright. So if the value of S is 0 and R is 0, this operation shows no change. That is, if currently my value inside my flip-flop is 0, then my next value will remain as 0. Similarly, if my current value is 1, okay, then if I pass 0 0 through SR, my next value will remain as 1. Okay, so this will show no change if I pass 0 and 1, 0 through S and R both. Now let's come to the next command. S is 0, R is 1. If SS0R is 1, this stands for reset. This means it doesn't matter what value was stored before, my next value will immediately become 0 because I am resetting my flip-flop. My flip-flop will become 0, okay? Next we have the set command. In the set command, if SS1R is 0, this is my set command. This means no matter what value was stored before, my next value will become 1, okay? My flip-flop will forget its previous value and it will store 1 inside it. And then for 1 1 it's invalid because in the previous circuit we saw that if when we give 1 1, Q and Q bar becomes the same, okay? So 1 1 is an invalid input. So these three combinations are important for us, and remember when SR is 0, when they're both 0, it matters what was stored inside my flip-flop previously, because whatever value that was stored previously, our flip-flop will retain it. Okay, so this was the characteristic table for SR. Does anybody have a question till now? Anybody any question? Okay. Alright, now we will learn about a new kind of a flip-flop which is very similar to SR, okay, but that flip-flop is a bit advanced because it allows the combination 1 1, okay. So that flip-flop, the name of this flip-flop is JK flip-flop, okay. So JK and SR flip-flop, they work in the same way for the first three states. So J works like set and K works like reset, okay. The only difference is in the last state. So in the JK flip-flop, this will work like J works like S and K works like R. So for the first three states, it's the same. That is, if JK are 0, 0, 0, then there is no change. If J is 0 and K is 1, this is for R, so the value is reset. And if J is 1 and K is 0, then the value will be set, okay? That is, our flip-flop will store the value 1 here. Okay, so this is the difference between, this is how JK flip-flop work very similarly as SR flip-flop, but there is one difference in the last state, okay? In the last state, what it does is, let me show you. So here, remember, this works like S and this works like R. So the first three stays the same, it remains the same. Now, interestingly, when we give 1 through J and 1 through K, what it does is it toggles our flip-flop. Toggle meaning invert, okay? Another synonym for invert is toggle. So if previously my flip-flop was holding 1, then it will toggle it. It will invert it and my next state will be 1. However, if my flip-flop was holding 1, then it will invert my current value and it will convert it to 0, okay? So let's say here I have a flip-flop here, okay, and I have 1 stored. If I pass 1 and 1 through JK, then my state will become inverted. So if it was 1, it will change to 0. If it was 0, then it will change to 1, okay? So JK, this is a special characteristic of JK, that if I pass 1 1 through it, it can invert the current state of my flip-flop. So since JK has a special feature, of course its circuit will be different as well, okay? So let's look at the internal circuit of a JK flip-flop. So can you tell me how is it different from SR flip-flop?
Ma'am, NAND gate is used in place of AND gate.
Right. Previously we had AND gate, here we have NAND gate. And what else?
we are using NOTs while getting the outputs.
This is, oh, by the way, this is still a NOT gate, or these are still NOR gates, okay, different notation. And what else is different? Look at the input of the NAND gate. Look at the input of the NAND gate.
There are 3 inputs.
What are the inputs? See, Q is given in this NOR gate, as well as this Q is also given as an input in this NAND gate, and Q bar is given as an input in this NAND gate. Okay, so this is how the circuit of JK flip-flop is constructed. And if you put the values of J as 1 and 0, you can see the values accordingly. So I'm not going to trace it for you. This will be a part of your homework, where you give the values of JK and you check whether it works like the characteristic tables or not. Like if I give 1 1, then the value will be toggled. If I give 0 0, it will remain unchanged. If I set the value, so JK, right? So SR. So JK, I remember it like this, JK SR. So if I want to store the value 1, then I pass 1 through J and I'll pass 0 through K. So pass these values and trace it. This is a part of your homework, and you will see that it works according to its characteristic table. Okay. All right. So in the next part, since we have seen the internal circuit, now we will try to find the equation for JK flip-flop. Okay. All right. Now, if you notice that I had two variables previously, I showed that QT and I showed QT plus 1. So QT is basically my memory element, that is what my flip-flop is currently holding right now. Okay, my flip-flop is currently holding QT. I want to take the input J and I want to take the input K, and I want to find out what my next state of the flip-flop will be. So the next state of a JK flip-flop, it depends what my currently what value my flip-flop is holding, because if it's no change, then my current value stays as it is. Okay, my current value becomes my next value. If it is JK is 1 1, if I pass 1 1 through JK, then it's important what my current value is, because my current value will be inverted. Okay, so my next value is denoted with QT plus 1, and my current value or my previous value is stored with QT. So my next state will be a function of QT. That what my next value will depend on what my current value is. Okay, what's stored in my memory and what is given in as my commands, which is basically my external input. Okay, so these are the external inputs and this is my memory element. Okay, so QT plus 1 will depend on QT and JK. So the JK flip-flop, the circuit, okay, QT plus 1, that is my next state. It will depend on these three inputs, J, K, and what is stored in my memory. Okay, so before we if we have to find the equation of a circuit, first we construct its truth table. Okay, so for truth table, we write the inputs and we write the output. Okay, so here my input is what is currently stored and my command, and the output is basically what my next state will be. Okay, all right, so you guys tell me, remember J works like S and K works like R. Okay, if J is 0 and K is 0, what operation does this denote? Guys, J0, K0 means S0 and R0.
Well, no change.
It shows no change. That means whatever my value is stored right now, this value will be shown in my next state. So if 0 is stored, my flip-flop will keep on storing 0. Okay, so if JK is 0 0, it matters what is currently stored. My currently is 0, so my next state will also be 0. Okay, there will be no change inside my flip-flop. It was 0 and it will remain as 0. Okay, now J is 0 and R is 1. What will be my next state?
Reset.
Right, it will be reset. Reset means it doesn't matter what my current value is, my flip-flop will automatically become 0. Okay, we will only look at the current value if it matters. If I'm resetting it, then it doesn't matter. Okay, how about here? S is 1 and R is 0.
Ma'am, set.
set? Set means, what does set mean?
1.
It doesn't, so set means it doesn't matter what my current value is, my flip-flop, the value inside my flip-flop will become 1. Okay, how about 1 1? If I give S as 1 and R as 1, sorry, JK, right? JK 1 1. 1 1 means what?
Ma'am, toggle.
Toggle. Okay, what will be toggled? So here it matters what my flip-flop is currently holding. Currently my flip-flop is holding 0. So if I invert it, my flip-flop will change its value to 1. Okay, toggled. Okay, now guys, can you tell me what will be the output, what will be my next state for this combination?
Ma'am, 1.
Okay, why is it 1?
Because previously it was 1 in the memory.
Right. And I'm giving 0 0, it means no change. No change means it will remain as 1. How about here?
Ma'am, 0.
Reset, right? It will become 0. Then here,
1.
because I'm setting the value, it becomes 1. And here,
0.
right, toggle, right? So previously 1 was stored, it will become 0. So I've toggled. Okay, so this is my next state that depends on my current value and the value of JK. Now to find the equation for QT plus 1, I need to find the equation. So for equations, what do? We draw the K map and we find the equation. So I'm not going to explain this part, I'll just show you how it was found out. So here it's going to be a 3 variable K map, 3 inputs. QT is the MSB, so I have QT and I have JK, and I've plotted the mean terms for which the output is 1, and this will be my equation. So my next state depends on QT into K bar plus QT bar into J. Okay, it depends on J, K and the value of QT. Okay, this process is very important, guys. Do not memorize it, you will, because you need to learn this for the rest of the flip-flops as well, right? But the technique is important. Alright, so we are done with JK flip-flop. Does anybody have a question up till this much? Anybody, any question? Alright, I'm assuming not. So in the next part, we're going to learn about a new flip-flop called the D flip-flop. And we've already done the hard part. If you can understand SR and JK, D flip-flop and T flip-flop will be very easy, okay? So let's look at the D flip-flop. So as opposed to my previous flip-flops, D flip-flop has only one, okay? It has only one input, and of course all flip-flops will have a clock. Remember that, okay? Clock works like the enable bit, okay? We might not write it, but it will always have a clock input. So for D flip-flop, it's very simple. D is called the data flip-flop. That is, if I want to store 0 inside my flip-flop, if I want to store 0, then what I'll do is I'll pass 0 through D. So if I pass 0 through D, my Q, the value of Q will be 0 and Q bar will be 1. So 0 will be stored. And if I pass 1, then simply 1 will be stored. Okay, there is no toggle, there is no change, there is no such thing as no change. In D flip-flop, if I want to store 0, I pass 0 and 0 is stored. If I want to store 1, then I pass 1 and then 1 is stored. Okay, this is how my D flip-flop works. Okay, now let's see how we can construct the D flip-flop. So the D flip-flop can very easily be constructed with the RS flip-flop. Okay, let me show you how.
working as a
So let's look at our SR flip-flop again. Okay, let's look at our SR flip-flop. Okay, in our SR flip-flop, if the value of set is 1 and R is 0, then I have 1 stored inside my flip-flop, right? And if the value of S is 0 and R is 1, the value of S is 0 and R is 1, then the value 0 is stored inside my flip-flop. So what I can do is, notice that if I want to store 1, then I pass 1 through S and I pass 0 through R. Okay, so simply what I can do is, I want the value 1 to be stored if D is 1, right? So I'll pass D through S. Okay, I'll pass D through S, and from R I need to pass 0, right? So what I'll do is, I'll pass D bar. I'll pass D bar through R. In such a case, if D is 1, then 1 is passed through R and 1 bar is 0, so 0 is passed through S, so my flip-flop will store 1. Conversely, if I pass 0 through D, let's see what happens. Okay, if I pass 0 through D, so if I pass 0, then S will have 0 and 0 bar is 1 and R will have 1. So what will be stored inside my flip-flop?
It will be 0, I guess.
Right, reset, right? Since we're resetting, so the value will be 0. So if I pass 0, then 0 is stored. If I pass 1, then 1 is stored. Okay, in this case we see that it is working like the D flip-flop, because in a D flip-flop, whatever value I pass through D should be stored inside my flip-flop. So this is how we can construct a D flip-flop using SR flip-flop. Alright, so now let's look at the characteristic table for D flip-flop. Okay, so let's look at the characteristic table. So for the characteristic table, this is the value of D, and remember, in a sequential circuit, in a flip-flop, always the output is the next state is written as QT plus 1, and the QT is my current value. Okay, so if the value of D is 0, it doesn't matter what my current value is. Okay, in a D flip-flop, it doesn't matter what previously my flip-flop had stored. If D is 0, my flip-flop is gonna store 0. If D is 1, then my flip-flop is going to store 1. Okay, so in a D flip-flop, it doesn't matter what currently my flip-flop is holding, because there is no such thing as no change and toggle. So if D is 0, then my output will be 0. If D is 1, then my flip-flop will hold 1. Okay, so from the characteristic table, this is my this is my characteristic table. So if I so now we're going to find the equation for D flip-flop. Okay, so for the D flip-flop, you see that my next state, QT plus 1, my next state will always be the value of D. Okay, it does not matter what my current value is. If D is 0, then my next state will be 0. If D is 1, then my next state will be 1. So QT plus 1, my next state only depends on the value of D. So this is the equation for D flip-flop. Alright, now we have our last flip-flop, which is called the T flip-flop. Okay, so for our T flip-flop, Okay, now we're doing T flip-flop. So again, my T flip-flop has only one input, okay? So it will have T, and also remember that the clock pulse is always there in my flip-flop, and it will have one output Q, okay, and Q1. So T flip-flop has only two operations, that is no change and toggle. So if I pass 0 through my T flip-flop, if I pass 0, guys, everybody please notice how this works. If I pass 0, then initially if 0 was stored inside my flip-flop, then Q will remain as 0. If 1 was stored inside my flip-flop, then Q will be 1. Okay, so if I pass 0, what it matters what was previously stored inside my flip-flop. If I had 0 stored inside it, then it will remain as 0. If I store 1 inside it, then it will remain as 1. Okay, and the next operation T has is toggle. That is, if I pass 1 through the T flip-flop, then if my previous state is 0, then can you guess what my next state will become? Can you guess what my next state will become? It will be toggle. So what will it become?
Then 1.
Right. So currently if 0 is stored and I pass 1 through T, then my next state will become 1. Okay, so 0 will change into 1. And again if I pass 1 through T, currently I am storing 1, okay, and my next state will change and it will become 0. So the toggle operation, whenever I am passing 1 through T, whatever value that is currently stored inside my flip-flop, it will be inverted. Okay, so if 0 was stored, it will become 1, and if 1 was stored, it will become 0. Okay, so now I'm going to give you guys 2 minutes. Can you guys think how we can construct a T flip-flop using a JK flip-flop? Okay, the T flip-flop can be very easily constructed using JK flip-flop. Can you guys think? Okay, can somebody tell me how we can did anybody figure out how we can use a JK flip-flop as T flip-flop? So what happens if I pass 0, 0 through JK?
No change.
Right. So when I pass 0, 0 through JK, whatever value that is inside my flip-flop will remain as it is. And if it is 0, it will remain 0. If it is 1, it will remain as 1, right? And what if I pass 1, 1 through JK? What does 1, 1 do in JK?
It will toggle.
It will toggle, right? If previous value was 1, it will change to 0. If previous value is 0, it will change to 1, right? So now can you guess? What if I have the T flip-flop? So what if I short J and K? Okay, let me short them, and I'll pass T. So if I pass T as 0, then they will both be 0, right? So it will be no change. And if I give 1, then both will have 1, 1 passing through it, and it will toggle. So the JK flip-flop, if we short it and we pass an input, this will work like a T flip-flop. Okay, so the JK flip-flop, because if I pass 0, 0, it will remain unchanged. So if T is 0, JK will both be 0, and it will remain unchanged. If I pass 1, then JK will both be 1, and JK both 1 means my if okay, let me remove it off. Okay, if J and K are both 1, this means it will do the toggle operation. Okay, so if you just short JK, it will become a T flip-flop. Alright, so this is how we can convert a JK flip-flop using a T flip-flop. Now let's look at the characteristic table for T flip-flop. Okay, so if T is 0, then the operation is no change. No change means if currently I have 0 stored, it will remain as 0. If I have 1 stored, it will remain as 1. If T is 1, it will be toggled, meaning if currently I have 0 stored, this value will turn into 1. If currently I have 1 stored, then the value will turn into 0. Okay, so this is the characteristic table for T flip-flop. Okay, now we have one last part left, that is the equation for T flip-flop. Okay, so if I want to write the output equation, again my output, that is my next state, will depend on my current state and the value of T. Okay, so it can be 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so you guys tell me, if my current state is 0 and T is 0, what will be my next state?
0.
It will remain unchanged, right? 0. Likewise, if T is 0, okay, let's look at, if T is 0 and my current state is 1, what will be my output? What will be my next state?
1.
It will remain as 1. Okay, so when T is 0, my next state will be my current state. Okay, and if T is 1 and my currently I have 0 stored, what will be the next state?
1.
It will be 1 because it will be toggled. So currently I have 0 stored, it will be inverted to 1, and what will be the output of the next one? For the last,
0.
it will be 0, okay, because it will be toggled. So now can you find the equation for Qt plus 1? What gate does this work like?
XOR gate.
Right, this is basically, so the next state will be the XOR between the current state and T, right? So this is, so Qt plus 1 will be Qt bar into T, or Qt into T bar. So this will be the next state's equation. Alright, so this is we have covered the 4 flip-flops, the basics. In the next class, we will do some applications. Does anybody have any question till now, up till this part? Any question, guys? Hello, any question?
ম্যাম আমাদের এখান থেকে কি রকম কোশ্চেন আসবে
It will see it in the next
একটা
class.
ফ্লিপ ফ্লপ থেকে আরেকটাতে কনভার্ট করা
Yeah, but conversion
Okay.
is very straightforward because we've already shown you, right? There are actually specific examples. We will do the examples in the next class.
ওকে
Alright, if nobody has a question, I'll stop the recording.